Alright gearheads, let's talk shop. Ever wondered what happens when you slam your foot on the gas pedal? It's like unleashing a carefully orchestrated explosion under the hood. Don't worry, it's supposed to be controlled chaos. We're talking about the heart of your car, the internal combustion engine. Pressing the accelerator sends a signal to the engine. It's like whispering sweet nothings, but instead of romance, you get raw power. The engine's response? Sucking in a big gulp of air, like a runner catching their breath before a sprint. This air is crucial. It mixes with fuel, creating a potent cocktail that's ready to blow. But hold your horses, we're not detonating bombs here. We need to control this explosion, harness its energy, and turn it into motion. That's where the real magic happens. So buckle up because we're about to dive deep into the belly of the beast. We'll break down the roles of pistons, fuel injectors, and all those other gizmos that make your car roar to life. Get ready to unleash your inner mechanic. We've got the air pumped and ready, but what about its partner in crime, the fuel? That's where fuel injectors come in. These tiny nozzles spray a fine mist of fuel into the engine, creating the perfect air-fuel mixture. It's like mixing the perfect cocktail, but instead of a hangover, you get horsepower. This mixture, my friends, is highly flammable. One spark and boom! It ignites, creating a powerful explosion that pushes down on the pistons. Think of it like a controlled explosion in a cannon, except instead of launching a cannonball, we're turning a crankshaft. But before we get ahead of ourselves, let's talk about these pistons. They're the workhorses of your engine, moving up and down with every explosion. Imagine a boxer throwing a punch. That's the kind of force we're talking about. This controlled chaos is the heart of your car's engine. It's a symphony of explosions, precisely timed to create the power that moves you down the road. And believe me, it's a beautiful thing to behold. Picture this, you're at a heavy metal concert, the music's thumping, the crowd's going wild. That's what's happening inside your engine, with the pistons headbanging to the rhythm of combustion. These cylindrical metal champs live inside the engine's cylinders. When the air-fuel mixture explodes, it pushes the piston down with incredible force. It's like a power lifter doing reps, except these guys never get tired. Now here's the thing about pistons. They don't just move up and down, they're connected to a crankshaft, which converts their linear motion into rotation. Think of it like a bicycle pedal. You push down with your leg, but the bike's wheel spins in a circle. Same principle here. So these pistons are taking the raw energy of those mini explosions and turning it into something useful. It's like channeling the Hulk's rage into something productive, like say, powering a 1967 Shelby Cobra. Now that's what I call power. We've got the air, the fuel, the pistons ready to rumble. But what lights the fuse on this whole operation? Enter the spark plug, the unsung hero of the internal combustion engine. These little guys are like the match that starts a bonfire. They deliver a jolt of electricity, creating a spark that ignites the air-fuel mixture. Timing is everything here, folks. The spark has to happen at just the right moment for maximum power and efficiency. Imagine a stand-up comedian delivering the punchline at the perfect time. That's what a well-timed spark is like. It's all about precision and timing. So next time you hear that satisfying rumble of your engine, give a little nod to the spark plugs. They're the ones setting the whole symphony of combustion in motion. Without them, your engine would be as useful as a screen door on a submarine. Section 5. From explosion to rotation, the crankshaft's role. We've got the pistons pumping, the explosions rocking, but how does all that raw power actually turn the wheels? That's where the crankshaft comes in, the maestro of motion. Remember those connecting rods linking the pistons? They're attached to the crankshaft, a cleverly shaped shaft that converts the up and down motion of the pistons into rotational force. It's like a conductor taking the individual efforts of the orchestra and turning them into a beautiful symphony. As the pistons move up and down, they push and pull on the crankshaft, making it spin. This spinning motion is what ultimately powers your car. It's the driving force behind your joyrides, your commutes, your escapes from the mundane. So there you have it. The crankshaft takes the raw power of those mini explosions and translates it into the rotational force that turns your wheels. It's a vital link in the chain of combustion, turning chaos into controlled motion. Section 6. Transmission, shifting gears and sending power. The crankshaft is spinning like a disco ball on a Saturday night, but how does that power actually reach the wheels? That's where the transmission comes in, the unsung hero of smooth acceleration and efficient cruising. Think of the transmission as the gearbox for your car. It uses a series of gears to adjust the amount of torque sent to the wheels. Low gears give you more power for starting and climbing hills, while higher gears allow for greater speed and fuel efficiency. It's like choosing the right wrench for the job. You wouldn't use a tiny wrench to loosen a stubborn bolt, would you? Similarly, the transmission selects the optimal gear ratio for different driving situations. So, the next time you shift gears, whether you're cruising down the highway or tackling a steep incline, remember the transmission working its magic behind the scenes. It's the unsung hero that ensures you have the right amount of power at your fingertips, no matter the driving conditions. Section 7. The differential making your wheels work together. We've got the engine roaring, the transmission shifting, but there's one crucial component we haven't talked about yet: the differential. This mechanical marvel ensures your car can smoothly navigate those tight turns without throwing a tire tantrum. See, when a car turns, the outside wheels have to travel a longer distance than the inside wheels. The differential allows for this difference in speed, letting the wheels rotate at different rates while still receiving power from the engine. Think of it like a pair of figure skaters doing a spin. One skater stays relatively still, while the other gracefully glides around them in a wider circle. The differential acts like the point of connection, allowing for different speeds while maintaining a cohesive movement. So, the next time you effortlessly parallel park or zip around a corner, give a silent thanks to the differential. It's the unsung hero that keeps your car moving smoothly, even when your wheels have different ideas about which direction to go. Section 8. Nitrous and octane, a need for speed. Now let's talk about something a little more exciting, something that gets the adrenaline pumping: nitrous oxide and octane ratings. These are the things that separate the Sunday drivers from the speed demons. Nitrous oxide, or laughing gas as it's known in the medical world, is a potent oxidizer that can give your engine a serious boost in power. Injecting nitrous into the engine provides more oxygen for combustion, resulting in a bigger bang and a surge of acceleration. Octane ratings, on the other hand, measure a fuel's resistance to knocking or detonation. Higher octane fuels can withstand higher compression ratios before igniting, allowing for more power and efficiency in high-performance engines. But remember, folks, with great power comes great responsibility. Modifying your car with nitrous or running high-octane fuel without proper tuning can damage your engine. It's like giving a toddler a chainsaw fun to watch, potentially disastrous in the wrong hands. Section 9. The future of driving, a sneak peek. We've journeyed deep into the heart of the internal combustion engine, explored its intricate workings, and uncovered the secrets behind its power. But the automotive world is on the cusp of a revolution, a shift towards a cleaner, more sustainable future. The rumble of the engine, the scent of gasoline, the thrill of a manual transmission. These are all hallmarks of a bygone era. The future of driving is electric, and it's coming faster than a Tesla in ludicrous mode. So buckle up, gearheads, because the next chapter in our automotive adventure is about to begin. We're plugging in, powering up, and exploring the exciting world of electric vehicles. Get ready for a wild ride. Section 10. Electric Avenue, the next chapter. Remember that feeling of anticipation you had as a kid on Christmas Eve? That's how I feel about the electric car revolution. It's a whole new world of automotive innovation, and it's about to blow the doors off everything we thought we knew about driving. No more pistons, no more spark plugs, no more oil changes. Electric cars are powered by batteries and electric motors, making them incredibly efficient and surprisingly powerful. Plus, they're whisper quiet, so you can say goodbye to those noisy exhaust pipes. But don't worry, gearheads, the thrill of driving isn't going anywhere. Electric cars offer instant torque and acceleration that will leave you grinning from ear to ear. It's like being launched from a slingshot, only smoother and without the risk of ending up in a tree. Section 11, buckle up for more. So there you have it, folks. We've gone from 0 to 60 on the internal combustion engine and taken a sneak peek at the electric future that awaits us. But our automotive adventure doesn't stop here. In our next installment, we'll dive deep into the world of electric cars. We'll explore the technology behind these silent speed demons, from batteries and motors to regenerative braking and autonomous driving. So stay tuned, gearheads, and get ready to plug into the future of driving. It's going to be electrifying.